You turn the page, the clock is ticking, and bam! You're staring at a terrifying multi-stage motion graph detailing speed, velocity, and acceleration, paired with a massive, impossible-looking data table. This is the exact moment grade boundaries shatter for most Cambridge IGCSE Physics 0625 students. A single misstep here costs you crucial method marks, and those mistakes cascade fast.
It's got curves, varying gradients, hidden anomalies, and a 6-mark evaluate command word just glaring right back at you. It is literally designed to induce panic. But what if I told you this terrifying past paper question is actually the easiest win on the entire paper? Once you stop treating it like a math problem and start treating it like a mark scheme puzzle, everything changes. Section 1. The painful mistakes.
Look, you can memorize every single equation for speed, velocity, and acceleration. But if you don't know how examiners actually award points for practical data and motion graphs, your marks are going to slip away. We see the same painful mistakes costing students top bands every single year. I'm talking about missing units on a final calculated acceleration, or rounding your data way too early in the calculation before you even reach the final answer. Students are constantly giving these vague explanations for the shape of a distance time graph, or worse, they completely flip their graph axis variables. We see weak practical improvements too, like just writing "use better equipment" instead of actually specifying how to reduce uncertainties. They pick the wrong variables, or they draw conclusions that literally have no support from the provided data table. If you're doing any of this, you're just leaving free marks on the table.
And that brings us right back to the master syllabus. If you look at Chapter 2 of the Cambridge IGCSE Physics coursebook on describing motion, you'll see exactly where this fits. We're talking about understanding speed, interpreting distance-time graphs, grasping acceleration, and calculating both of them. But here's the crazy part. Examiner reports show that over 60% of lost marks in this specific section aren't from bad math. They're from failing to translate those textbook concepts into real measured data. You aren't just being tested on formulas here. You're being tested on how well you connect those formulas to reality. Section 2. The high mark answer framework. Now, in just a moment, I'm going to show you the one specific examiner clue that changes your answer completely. It's a subtle trick they use in motion graphs that reveals exactly what they want to see. But first, you need a framework that actually makes that clue obvious.
This is a 4-column breakdown that turns passive knowledge into active mark scheme thinking. When you're faced with a describe, explain, or evaluate question about a motion graph, you absolutely must filter your answer through these 4 steps. First up is the concept. Ask yourself, what is the core physics principle here? Is it constant acceleration, terminal velocity? Second is the evidence or data. You've got to pull a specific number, a gradient, or a coordinate directly from the source graph or table provided. Do not skip this. Third is scientific reasoning. How does the equation or method actually connect that evidence back to your core concept? And finally, the 4th step is examiner wording. You need to wrap your answer in exam-safe phrasing and correct terminology. Stick to this 4-part chain, and you are guaranteed to hit every single method mark.
Section 3. Spot the flawed answer.
All right, let's put this into practice. I want you to actively engage with this explainer right now. Pause for a second and predict. When you're looking at a practical data question that asks you to calculate and explain the acceleration from a speed-time graph, where do the missing method marks usually hide? Think back to that 4-column framework we just talked about. What's the most common thing students leave out?
Let's break it down. A classic flawed student answer goes something like this. The object gets faster because the line goes up and the acceleration is 5. Honestly, in casual conversation, that sounds fine. But to a Cambridge examiner, total disaster. It's vague, and it's completely missing units. Now, check out the improved top band answer. The object undergoes constant acceleration of 5 meters per second squared. This is evidenced by the constant positive gradient from t equals 0 to t equals 4 seconds, calculated using the change in velocity over time. See the difference? It nails the concept, pulls data straight from the coordinates, provides scientific reasoning using the gradient, and wraps the whole thing in perfect examiner wording.
And this is exactly what the strict mark scheme logic demands. Put yourself in the examiner's shoes for a second. I can't give you full credit just because you know the object is speeding up. A strong answer absolutely must include substituted values. That means showing the exact numbers you pulled from that source graph right alongside the units where they're needed. You also have to show complete command word fulfillment. If the command word is evaluate, just describing the graph isn't going to cut it. You have to actually judge the data. Using correct terminology and proper variables isn't just an optional bonus, it is the entire point of the assessment.
Let's build on this with a crucial reminder from the practical data coach approach. Listen, even if your math is absolutely flawless, If you ignore the practical checks, you're saying goodbye to that top grade. You have to check your units and your significant figures every single time. Double-check those graph scales too. Examiners love to throw in non-standard increments just to mess up your coordinate readings. And always keep an eye out for anomalies that might affect the reliability of the data. Plus, when they ask for practical improvements, you got to be specific. Say something like, repeat the experiment and calculate a mean to identify anomalies. Don't just write, do it again carefully. That won't get you the marks.
Section 4. Your final missing piece.
Okay, so you now know exactly how to map Chapter 2 concepts onto the 4-part framework, and you know how to pull substituted values from graphs. Step 1 is officially complete. You've mastered the graph framework. But here is the massive problem. Step 2, unlocking the top-band evaluation skill for linked practicals, remains completely locked. When Cambridge throws a complex linked data analysis practical at you, one where multiple variables interact and you actually have to evaluate the experimental design itself, the framework we just covered is only half the battle. You need specific, high-tier evaluation skills to guarantee those final, boundary-pushing marks. And that final, crucial missing piece? It is only found in our next explainer.
You literally cannot afford to take your physics exam without that top-band evaluation skill. It's the mandatory next step to completely dominate this paper. Why do all the hard work on the math, just to let the final evaluation marks slip away? To unlock that final framework, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Click over to the next explainer right now and let's secure those 4 marks.